Hello. Hello, everyone. Can you hear me? Hello. Can you hear me? Hello. Can you people hear me?
Yes, I can.
Okay. Thank you so much. Ladies and gentlemen, I want to take this singular honor to welcome you to our today's Green Masterclass on behalf of Crust Eco Network Initiative for Sustainable Development. My name is Jacqueline Katsale. I'm from Uganda and I'm serving as the ambassador of Crust Eco Network to Uganda. And to our audience today, we are exceedingly blessed to have our esteemed facilitator, Miss Ananya Aithal, who is a cybersecurity engineer based in India, specializing in sustainable software development. As a lead mentor for Crust Eco Network's Green Computing Masterclass, she empowers African youth aged 18 to 35 years through hands-on coding demonstrations that bridge the technology and environmental responsibility. Her sessions feature live energy-efficient algorithm comparisons, real-world banking sector case studies, and interactive carbon footprint calculators that make green computing practical and accessible. Ananya is also passionate about equipping the next generation of African developers with the skills to build a sustainable digital future, proving that environmentally conscious code is not just ethical, it's a better code. So, ladies and gentlemen, today let's all come together to welcome our esteemed facilitator. Let me see some cheers from the class. Cheers to our esteemed facilitator. To our dearest facilitator, I want to take this opportunity to welcome you today. And I'm just eagerly waiting to hear from you and someone who is passionate about environment. I'm quite sure that I'm going to enjoy this class, and I believe that the rest of the team that is tuning in will also enjoy your class. So I hope you take on now. Thank you.
Thank you so much, Jacqueline. If I may request the Crustico Network team to share my slides, and it'll be good.
Yes, please.
I've asked the team to share my slides. So
Yeah.
could you please share it from your system?
Okay, let me check here. Stanley, can you help me share the slides if you can? My system seems not to be showing the slides here. Hello, Stanley. Can you help me share the slides? My system doesn't share. It's not sharing. Yes, Ananya, do you mind sharing the slides if your system can share the screen?
Okay, I'll do it from my end.
Okay, thank you.
Can you see my screen?
Yes, please, I can see it.
Okay.
Yeah, thank you.
Thank you everybody for joining this session. I'm really excited to be kicking off our masterclasses with Crust Eco Network, and I'm thankful that the team has given me this opportunity to kick off the classes with something called green computing. I had presented this topic to the different masterclass cohort, and I found that I got a very good response from all the students that I presented to, and hence I've been given the opportunity to do it once again to a larger and bigger audience with much more enthusiastic students in Africa. Thank you so much to the team, and let me just begin my presentation here. So I'll start off with what is green computing. There are four parts to this, and the first and most important part is its environmental impact. It involves designing, manufacturing, and using technology while we minimize our environmental impact. Green computing also talks about reducing energy consumption and carbon emissions. Green computing also involves making sustainable hardware, which is something that you all must have heard of. And it is more important to know what green computing actually does and why Africa matters in this conversation. And if there are any real companies in Africa that are doing this right now, how it affects careers like mine, and what are the concrete steps for you all. And let us start with this. I'll move on to the next slide. Why Africa matters. This is the most important slide of my presentation. Africa is not peripheral to the green computing story. Africa is central. 4% of global emissions and 75% of climate impacts. This is shocking. Africa produces very little of the carbon that's warming the planet. But Africa is suffering the most from climate change, droughts, floods, famine, the resource scarcity, etc. It is fundamentally unfair. The countries that caused the problem suffer the least. The countries that did very little suffer most. So, when we build technology for Africa, we have an opportunity to build it right from the start. And we don't have to retrofit. We don't have to go back and fix it. We can design for the constraints Africa faces. Not only that, 1.3 billion people accessing tech for the first time. Africa's population is huge, and most of them, maybe 80%, are accessing smartphones and internet for the first time right now in the next few years. That's the biggest technology adoption wave in human history. 1 billion people coming online. What if every first time internet user in Africa accessed technology that was already optimized for efficiency? What if our devices had 30-day battery life, not 1 day? And what if our apps were lightweight and fast, not bloated and slow? That becomes normal, and that becomes the baseline globally. The opportunity here is that Africa is not behind the technology curve. Africa is ahead because we have to solve hard problems right now. And that makes our solutions more robust, more efficient, and more valuable. When you're forced to design for constraint, you design better. With that, I would like to present some real life use cases to you all. And the first and foremost, or the most important thing, is agriculture and climate. I will show you some real companies in Africa that are doing this right now. One of them called Farm Crowdy, and this is my focus today. Farm Crowdy operates in Nigeria. They deploy IoT sensors on farmers' fields. Temperature, soil moisture, light, humidity is all monitored via these sensors. The challenge is that sensors are solar powered, but data transmission is expensive. Nigeria's data costs are high, and every transmission drains battery. Farm Crowdy solved this with smart triggers. Sensors check data every 5 minutes, but only transmit if something significant changed. Another example is of healthcare in Ghana and Kenya. Solar powered clinics are becoming common. Telemedicine needs servers, and servers need power. If you're running a clinic on solar panels, you can't afford to power a cloud server 24/7. So, what do? They run the AI models locally. The doctor takes a photo on their phone, the AI diagnoses it on their phone, and no cloud upload. The result is instant diagnosis. It is clever, efficient, and practical. We also use it for weather prediction, which is another huge use case. Coming to finance and infrastructure, you probably use mobile money, and maybe you've sent money via M-Pesa, Airtel Money, or something similar. That system is green computing in action. M-Pesa was designed in 2007 for phones from 2005. Old phones, no smart features, limited battery, slow data connections. So, Safaricom designed it to work on those constraints. Minimal data, simple interfaces, works offline, syncs when connected. Today, M-Pesa handles billions of transactions on devices that most technologies would say are too old, but they work beautifully. That's because the design was smart from the start. There are other various applications like blockchain in Africa, smart grids, education, training, etc. What I want to highlight with these real life use cases is that green computing is not just a concept, but it is something that you see in real life. Coming to the next slide, I would like to talk about how green computing affects my work. As Jacqueline introduced, I am a cybersecurity engineer at Standard Chartered Bank. I've been at Standard Chartered for less than a year, and when I talk to people, they ask me about my background. What do I study? What interests me? Why banks? I tell them that I'm interested in making systems more efficient, using less energy, less waste, more impact. They say, great, we need that. And that's the environment I'm in right now. And I think it's more important that you understand what this looks like from inside a major company. Standard Chartered Bank has massive data centers across multiple continents, massive computing power, and data centers consume an insane amount of electricity. 2 to 3% of global electricity consumption is data centers. That's roughly the same as aviation, and the number is growing. The bank spends millions on electricity bills, and beyond the cost, there's increasing regulatory pressure. The regulators are asking, What's your carbon footprint and what are you doing about it? So, suddenly, energy efficiency isn't just green virtue, it's a business requirement, it's a regulatory requirement. I am building AI tools to help with security audits. We process a lot of security logs and a lot of data. That's why green computing is in practice in my actual job. Something that I notice is that every new job posting at the bank now includes something about sustainability. Ensure energy efficient operations, designed for minimal carbon impact, optimized for resource conservation, etc. 5 years ago, that wasn't there, and now it's the standard. And if you are interviewing someone and they can demonstrate that they think this way, that means that they stand out and they're instantly more valuable. Coming to the next slide. This slide talks about how we see green computing in your daily life. As a student, let's talk about you, not future you, the current you. Your phone. Do you notice anything about your battery? By the end of the day, how much battery is left? 10%, 20%, nothing? That's not always about the battery capacity. It's often about app efficiency. An app that's poorly optimized drains battery 3 times faster than a well optimized one. Have you ever felt like your phone got slower over time? Yeah, that is often called bloatware, unnecessary processes running, and inefficient code. Have you ever noticed that some apps are snappier than others? Same task, but one app does it in a quarter second and another takes 2 seconds. That's something called efficient versus inefficient coding. You feel the difference in your hand, in your experience. This is a green computing decision. Similarly, we might have identified such scenarios when you're streaming. For example, this masterclass is being live streamed on YouTube and it uses about 0.17 kilowatt hours of electricity. If 10 of you stream 1 hour of video today, that's 1.7. Sorry for bad voice. I have a sore throat today. That's 1.7 kilowatt hours times 365 days, 620 kilowatt hours per year just from streaming. And by this, I'm not saying stop streaming. I'm saying the app you use must be efficient. The video player that you use must be efficient. And the platform, the engineers who built it, made choices that affect your power consumption. Those are green computing choices. Now, let's talk about the future you, the career you. If you land a job in tech, any tech role, the job description now includes sustainability and it's not optional. Google publishes sustainability reports, and Microsoft has carbon negative commitments. AWS, which is Amazon Web Services, has renewable energy targets. Startups are hiring specifically for green engineering roles. And the people who understand this, who can think about efficiency from day one, they earn 20 to 40% more than engineers who don't care. That's not a guess, that's market data. And companies are paying premium for this skill. With that, I would like to show you some career paths in green computing. We have various career paths, but these are the four topmost ones that I have highlighted, along with the skills required, the salary range, and how it is currently in the African job market. So you can take a look at these career paths when I share my slides later as well. And this is another important slide that I wanted to share with you all. You would have heard of Sustainable Development Goals that have been published by the United Nations. I would like to show you how green computing aligns with these Sustainable Development Goals. This matters beyond career, and this matters for the world. The UN has 17 Sustainable Development Goals and global targets for a better, more sustainable world by 2030. Green computing aligns with at least five of them directly. SDG 7 is for affordable clean energy. The goal is to ensure access to reliable, sustainable energy for all. Green computing helps by reducing demand. If we use 30% less electricity for consumption, that's 30% less grid pressure and 30% less demand for coal power or diesel generation. SDG 9 talks about industry and innovation, and the goal is to build resilient infrastructure and foster innovation. Africa does not have to follow Silicon Valley's 2005 approach. We can leapfrog to 2025 thinking, build companies that are green from day one. We can also talk about how it aligns to responsible consumption. This is the e waste piece. Right now, 95% of electronics are consumed in the global north, but 95% of e waste ends up in the global south. That's not responsible consumption, that's exploitation. Green computing includes designing products to last, making them repairable, ensuring responsible end of life. And that is responsible consumption. It also aligns to climate action, equality, and reduced inequalities. So, when we talk about green computing, we are not talking about environmental guilt. We're talking about the future of development, innovation, and opportunity in Africa. This isn't something happening in California that Africa should pay attention to. This is something Africa is uniquely positioned to lead. Now, I want to show you what this looks like in practice. So, I have a live demo for you. Let me just share that quickly. Are you able to see my screen?
Not really.
Okay. Are you able to see it now?
Yes, please.
Okay. So, this is something that is very exciting that I have built especially for this masterclass. I was talking to you all about Farm Crowdy and how they deploy smart IoT sensors across the field to monitor temperature, humidity, etc. So this is something very similar to the Farm Crowdy app. Just to see, I want you all to visualize how it actually looks on an app. Imagine that you are a farmer who has say 5 hectares of land, your app will look something like this. You will not be on the field to monitor each and every part of your farm to say how much temperature is on, say, plot A, or what is the humidity, and what are the requirements of my crop A, crop B, etc. Everything is monitored via these IoT sensors, and you can see this real time data on your app. You can see also on the app that what is the average temperature across your field, the soil moisture content, the alert response, the battery life of your sensors, etc. And you can also see the status of your sensors. Here it says alert. If you can see, it means that there is something wrong going on in your sensor S3. And the green color says that these sensors are operating fine. And why farm crowdy comes into this picture, into this example that I'm showing, is because of what kind of green computing technology is used by farm crowdy. They do not send the status of each and every sensor on your farm to the app. That will just overload the app. So what they do is, in case there is some kind of malfunctioning going on in any one of the sensors, then only an alert will be sent to the system. I will get a notification on the side saying sensor S3 has stopped functioning, or the temperature in plot B is exceeding its optimal limit, or something like that. So I hope you're trying to understand what I'm saying. If I get 100 notifications saying sensor S1 is okay, S2 is okay, S3 is okay, S4 is okay, it'll be too much for me to read each one, right? So what Farm Crowdy does is it only alerts me when something is wrong. And apart from monitoring the real-time health of the sensors, I can also see what is the aggregate temperatures, the reduction of carbon footprint, your battery life, etc. And I can also compare, saying what the good triggers or the smart triggers are, the ones that I was just talking about now, triggers that are sent to the system only when something is wrong. Bad triggers are something that is sent every minute. Every minute, if I get a notification that sensor S3 is okay, S3 is down, it'll overload the system. So green computing talks about using something called smart triggers. And I can see all that via this app. And when I say that there are good triggers and bad triggers, it's not just going to impact the carbon footprint. It will obviously also have a cost impact. And I've just put a projection as to see how you can save annually just by using these different kinds of triggers in our sensors. And with that, I would like to end this presentation. I hope you all had a great time and you could take something valuable from this session. And please let me know if you have any questions. I will always be available to answer them. Thank you so much, Crustico Network and Jacqueline, for being such a wonderful moderator.
Well, thank you so much. Thank you so much, Ananya, for this wonderful session. It's been so valuable to me. And like we say, learning is a continuous process. And and to me, I learned a lot as someone who is a lifelong learner. I've learned a lot, some things that I didn't know. And it's been a pleasure seeing your presentation connected to the different SDGs, the Sustainable Development Goals for UN. And I believe that the team, the audience, has been able to pick out something for themselves. So it's at this moment, we welcome everyone with the questions. And when the questions pop up, I'll be able to read them for you. Then you can answer. Then also in your presentation, if I would compliment, I have also all along I've been questioning myself that Africa is the least producer of the least producer of things that contribute to the different greenhouse gases, but we suffer the most. And I was asking myself why. But from this presentation, I've got to learn something. And still, like you've said, it starts with us. And I've also been able to learn how green computing is practiced in our daily life, something that most of us use not to take attention to. For example, you would use your phone drains so fast, and you you can't relate it with green computing. So at least now I have a view, and I've gotten to learn more about how green computing is practiced in our daily life. So at this juncture, I would like to welcome questions. Any questions for our esteemed facilitator? Can we get questions for our esteemed facilitator? Any questions you have about her presentation? If you want to ask something about the SDGs in line with green computing, our facilitator is here for you.
I see a question on YouTube.
Okay.
Maybe I can answer that.
Yes, please.
Let me see. Okay. Someone says, you talked about how the global north is mostly the cause of climatic problems we have. May you please elaborate? Okay. So, by that I mean that Africa produces about 4% of global greenhouse gas emissions. That's roughly 1.3 billion people producing 4% of the world's carbon. The United States produces almost 15% of global emissions for only 330 million people. And the Europe, another 10%, and China is 30%. So, what I'm trying to say here is that the richest countries that are in North America, Western Europe, and developed parts of Asia, they produce the industrial revolution, the coal economy, the oil economy. And for 200 years, they've been burning fossil fuels, building wealth and infrastructure. And they have dumped most of the carbon into the atmosphere. And Africa, they do not have centuries of coal plants and the same carbon footprint per person, but still they are experiencing 75% of climate impacts. And this is what I mean to when I say that the global north is dumping carbon footprint onto the global south, which includes Africa as well. So I hope I answered your question. Thanks for the question. It was very good.
Well, thank you so much, our dear facilitator, for that question. Um, there's another one here. Someone is saying, in line with farm, cloudy app. I know it's easy to get the app, but what about the monitoring tools in the farms? Or they are both different in line with farm cloudy app. What about the monitoring tools in the farm? And then all they are bought differently. Are there standards that govern green computing? Then the other one is, how can we link sensor critical alerts with AI advisory service to fill the gap of lack of extension services? So there are two questions here. Have you got the questions, Ananya?
Yeah, I can see the questions. There are a lot of questions pouring in.
Yes. Yes,
Maybe
please.
I'll answer a few of them. Okay,
Okay.
let us see. Easy to get the app, but what are the monitoring tools in the farms? Okay. Okay, so before we even talk about software strategy or an app, let's talk about what is physically deployed on the farm. In Farm Crowdy, they actually deploy actual IoT sensor nodes, and these are small devices that can be placed in the soil on the farm. And the app is secondary; it comes after you deploy all these sensors on the farm. And these devices, how you can get these is Farm Crowdy. They partner with sensor manufacturers, and these are imported from China or India. And you might have heard of companies like Libelium. And there are a few local assemblers in Lagos as well who combine these imported components. So yeah, that is for your question, Oliver. Let me see. Can you share the slides? Yes, I can. And how can the integration of green computing practices contribute to sustainable development in communities, particularly among marginalized groups? I think this is a great question. Okay, so the problem is that around 400 million Africans they lack reliable grid electricity, and that's not a minority issue, and that's most of the continent's problem. And we know that without electricity, we cannot charge devices or run servers, etc. And how green computing can change this is y- when we attain reliable grid power. And for that, we build something called cloud infrastructure. This is the traditional tech approach that's been taken. And what this does is that it doesn't work in rural areas, it only reaches urban centers. And when we talk about marginalized groups, this is where the whole part of inclusivity also comes in. And for that, we have the green cloud solution, which means to say that we use lesser data centers, lesser physical data centers. And when we limit the use of physical data centers and we start using cloud, we don't have to think of limiting the geographic capacity. What I mean to say is that, say, if location A and location B are there, and I want to set up a data center in location A because it is more urban and it's more tech and it's more like Silicon Valley, etc. And they'll get most of the benefits, while location B is not going to get so many benefits. I want to rectify this using green computing. So when I say that, I will not even be constructing a physical data center. I will be having a cloud data center so that both location A and location B can you make use of this data center. Okay, so this is what I mean by how green computing can help even marginalized groups. It's a very good question, and we can go even deeper and think about other possible effects of green computing on marginalized groups as well. Great question. Thank you so much. Uh, okay. How much more time do I have, Jacqueline?
You have 20 minutes left. Hello, Ananya. You have 20 minutes left.
Yes, okay, I heard you. Let me take up then another question. How green computing uses energy efficiency? Does it affect them more than they gain? Another very interesting question. And let me break it down for you all. How green computing uses energy efficiency. Okay. For example, you all must have heard of algorithms. And if you have not, an algorithm is just a piece of code that performs something for you. Say I want to have a list of numbers 5, 1, and 2, and I want to sort it in ascending order. It'll become 1, 2, and 5. But I do not want to do it from my end. I do not want to calculate it or arrange all these numbers and see which is greater, which is lesser. No, I just want a piece of code to do it. And that's why I write an algorithm that can write that can sort these numbers. Okay. So green computing can reduce energy through algorithm optimization. When we just write better algorithms or more efficient algorithms, we are automatically reducing our carbon footprint. And there is also something called edge computing. You all must read about it. It is very exciting. It is where we don't use any, say, online data centers or something. We code everything locally on our local system. There is something called smart data transmission, and there is code efficiency and using good hardware with good, what do you say, recent hardware updates, etc. And these are some ways how green computing can use energy efficiency. But you're also asking how does it affect them more than they gain? Yes, it does affect, to be honest, but only it is if it is done right. So it does have a massive cost reduction impact, and this is, I think, how there is more profit in using green computing as compared to all the, say, infrastructure costs, etc. Good question. Again, nice. Okay, let's the energy policy for developing country states. Energy must be made available first. Okay. Joshua is asking that question. Let me take this up. Maybe this will be the final question. Policy for developing country states. This is a critical question, and this is actually the real tension. And let me address this head on. Developing countries, they are saying that they have 400 million people without electricity, and we can't tell them to wait for solar panels while they live in darkness. And we need energy now. We need coal plants, diesel generators, natural gas, whatever works the fastest. It is not wrong, it is honest, and it is survival. Climate change is a luxury concern, to be honest, and poverty is something that is happening now. And this creates a conflict in the real world because these two goals seem opposite to each other. The first goal is energy access, and the second one is climate action. It feels like those two are contradicting each other, and these seem mutually exclusive. So how can I bring in the concept of green computing? Is that green computing does not say use less energy, so you don't need to build more power. Green computing is saying build power capacity efficiently, so you need less of it. I think this kind of flips the equation, and I hope I tried my best to answer this question and provide some insight into this. Thanks, Joshua. And thank you all again. Thank you, Jacqueline. I think we all had a wonderful time, and I hope you had something to take away from this. If you have any more questions, feel free to mail it to the Crest Eco Network team, and I have given them my mail and my LinkedIn on all my other social media as well. You can contact me anytime for any kind of questions or content. Thank you so much.
Wow, thank you so much, Ananya. It has really been an inspiring session. So at this juncture, I want to welcome Stanley to give a vote of thanks to our esteemed facilitator. You're most welcome, Stanley.
Okay, thank you very much. Thank you, Ananya, for this wonderful section. It's actually a good time always having you, having to discuss green computing with you. Thank you for this staying with Cross Tech Network. Jacqueline, you've done so well. Thank you very much. And all of these participants out there listening and taking notes. It's actually a very good one that you're listening. Uh, when we talk about green computing, it's actually very bulky, right? Yeah, and this is a 6 week class, and it needs a lot of understanding, a lot of structures, a lot of background. For a mentorship phase, many of you would might be interested in understanding more in green computing. So probably you can come up with a project that aligns with this when we put up a form for that. And as long as the session goes through, there'll be a form for that. So if you're interested in this form, which I hope everybody should be interested, yeah, you can now do well to come up with an idea that address all of these challenges we are facing environmentally. Yeah, we have already understood how that uh, green computing is an environmental responsible design. Yes, yeah, it's an environmentally responsible design. Yes, all of the e-waste we talk about today, you can't just address them without talking about green computing. Yeah, and I think Cross Echo Network is unique about that because I think we are one person handling that right now. So you can come up with projects that aligns with this. Yes, it's a 6 week class which will be ending by March 13. You would have the opportunity to come up with projects that would align with this and would be cost efficient. Yes, something that you can handle while we see how we mentor you in this process. A proper roadmap will be drawn and shared with you. We still have our sessions by 5 p.m. West African time. We would also like that you put up all of the energies already. Yeah. And if there are any technical challenge you experience, do well to communicate. The team, the admins of the WhatsApp platform would respond to everything. Yes, and the attendance form that has been shared with you has a part that would take all of that and we'll review it and know how we're improving all of those things. Thank you very much, everyone, for joining the call. It's always been a pleasure having you. We hope you enjoy your session. Yeah, thank you very much. Yeah, we call it a day. Yeah.
Okay, thank you so much, Stanley, and thank you so much to our listener for tuning in. See you next time.
Thank you all. Bye bye.
Bye bye.